Well, let me just go ahead and get started. The first thing we'll do is we'll talk about the exam. In other words, I will give you guys the solutions. Thank you for cooperating. Yeah. All right. Well, I'm going to return the exam to most of you today, even though some people, like 2 or 3, would not be getting it back because I didn't get your exam until earlier today. It has not been graded, but I'll return it to you, not so that you can grade it, but because I have scanned every single page on my scanner. So now I can grade it using my 1.2 gigabyte file. My PDF is about 1.2 gigabytes because there are about 300 and something pages that I scanned, and but that makes it very convenient because I don't have to carry a big pile with me all the time. I can just rely on a PDF to read it, and I can return it to you so that you can actually look at your exam when we talk about the solution. So I think that's good. It also means I can defer the grading of exam 1 almost indefinitely now. I'm just kidding.
So not funny.
No, not funny. All right, so I'm gonna give these back to you. Dino, okay. It's not graded, and you can use a pen of different color to make marks if you want to. Benjamin, Ross. Is Ross here? Nicole. I scan everything first. Okay, this one, Cameron. I think first name is Cameron. Cameron, not here. Yeah, penmanship is kind of important, because sometimes I cannot read what people write on these things. Chand. Chandel. Troy. It's okay to pass it along because there's no grade on it. There's no issue. Clifton. Clofton. Well, the first thing I had to do was to sort it first. Okay. Have you ever tried to sort like 51 paper like these? It's not that easy. So I had to use an algorithm. If this is an algorithm class, I have to use the merge sort algorithm. Look it up. It's actually pretty handy. I'll talk about it when it's time to talk about it. Clover, Aaron, okay. From here. Oh, here. Dean, go. Duran, Miguel. Last thing is Feeden, F-E-D-E-N. Felton. It's all alphabetical, so you kind of know when yours is coming up, unless you accidentally write down your first name as your last name. Sure. I think I scanned yours, except, if I scanned it correctly, I should not have these loose pages.
Well, I think you actually did scan them. They were all stapled together to begin with, but when you stapled them, so these are shorter.
Okay.
So they might have been scanned.
I think they might have been scanned. Marcia. Here. Harlan. Isaac. Kremlin. one is forgot about the last name first thing. First name is Vadum, last name is K.R. Lennon. Washi. Ken is an Anfield. Last name is M-A-N-T-H-E-I. McNeil, Christopher. Is Christopher McNeil here? Al. Merrill, William. Sorry. William, Ryan. So what I'll do is I'll go over all 20 questions because each question has 5 variations. Miller. Miller.
Yeah.
Sean. Matthew Owens.
Sure there.
Patrick. Last name is Reynolds.
He just passed.
Rosslyn. R-O-S-L-A-N.
He just passed back test.
Next one
Test.
is Ross.
Said he's not passing back cars.
Who's?
Me and you, we just picked him up this morning at the lab.
Oh, I turned mine in the other day.
Sater. S-A-E-T-E-R-N.
Wow.
Mine was brutal.
I just left it there.
He's left it back.
I was saying that for some reason they're supposed to turn it in to people for tests. He said he just found it.
Stafford.
Maybe it's your
First name is Karen.
Retrace backwards.
Tang, T-A-N-G. I don't think it's
I
here
don't
yet.
think he had to retrace it backwards.
No, it wasn't
Michael?
retrace, but it was like prove
Like they
that,
had to find it and
prove
then
that
trace it back.
pre-one is pre whatever.
Jeremy Trees.
I didn't bring any notes either.
Bo, B-O, last name.
Someone stole my bag, but he's not so bad.
And last name
Like
is
here?
E-S.
No, I ordered
A-R-I.
this little ass bag. Laptops, come on.
Williams. Cody.
Right.
Last name is Yan, Y-A-N. Last name is Yan, Y-A-N-G.
Laptop, books, glasses,
So you're
matrix
Y-A-N.
calculator.
Alright. Now most of you have your exam in front of you, except for people who came in a little bit late.
Sorry. Isaac Hammer.
Yep. You forgot to put your last name first. So we'll talk about that too.
Okay.
I don't think we got that memo because we weren't in here.
Hmm?
I don't think we got that memo because we weren't in here. Oh, never mind.
All right. So what we'll do is, we'll talk about the exam questions. If you have any particular question about the, all these questions or the solution, today is a good day to ask. I may not be able to finish, all the questions because I'm going to go over all 5 variations of each one, unless you guys stop me and say, please, that's too boring, keep going, move on to the next one. Because somebody, and I think most of you, will realize, hey, they are so close, it doesn't really make sense to talk about each and every one individually. Okay. Here we have the archive, and I'm going to uncompress it first to today's folder. So if you want to look, at the questions, just go download today's folder. It'll all be there. And feel free to share this with your friends and family and whatnot, because that's the whole idea of giving you back, the exam so that you can have a copy. I don't need to keep your copy. Hmm? I just kept a Xerox of it, yes. Capture the soul of your exam. Now the copy that you're holding is a zombie. It's just an undead. Okay, so here's question one, or one variation of question number one. Let me magnify that a little bit so that we can see better. That's good. All right. So basically, there are 5 variations of something like this, and they're all very similar. They all have a loop on the outside. They all have a conditional statement in the inside, and the conditional statement in the inside would jump the value. Okay. In other words, in this case, the value of x is not going to get decremented, continuously. The conditional statement will actually make it jump, a few steps, or 1 or 2 steps. Okay. So from that perspective, I think all of these are equivalent. Okay, all variations are somewhat equivalent. Let's go ahead and try to answer this question. And what I'll do is I will put this one on the side. I'm not even going to copy and paste it into the spreadsheet. I'm just going to use the spreadsheet to answer this question. Are there any specific questions or concerns or comments about question number 1? About the question type itself, about how it is asked, that sort of thing? Nope, no questions? Okay, that's not what I want to do. Somehow it always ends up doing this. Okay, do it again. All right. All right, let's see. I did a few steps, and I was even kind enough to give you the headers, the heading of each column, so that you don't have to worry about, what columns you need to use for these questions. Comments, line number X. Is the amount of space, appropriate? Does anyone feel that it's too small, you need more space next time or something like that? I know my second grader would need more space.
The second question, definitely more space.
The second question? Yeah, the second question I saw a lot of people, giving me extra sheets of paper. So we'll take a look at the second one. The second one is definitely one of the most difficult questions. All right. So with this one, we start with the precondition, and we can basically assume x, we don't know anything about x because the very next line, the first line of this program, is going to override the value. So it's okay to say that the precondition is nothing. Okay, we don't know anything.
So you can leave it blank.
No, you cannot leave it blank. Leaving it blank means you did not say anything.
Okay.
You have to say something to say that you don't know anything. There is a difference. Okay, so the next line is line 1. Line 1 is an assignment statement. X gets changed to 6. Line 2 is the conditional statement. This is the first time we get into here. The question is, X is greater than 1. Is it true or is it false? It's true. We go to line 3. Line 3 is another conditional statement, or it's another condition to evaluate. But this is not a loop. This is a conditional statement. So the question is, does x equal to 5?
False.
That's false. Then where do we go?
6.
And we do line 6. Very good. In other words, what I'll do is I'm looking for this transition here. So what I'll be looking for is whether people understand the conditional statement, the behavior of a conditional statement. So I'll be looking for the condition evaluating to false on line 3. And then skipping to line 6, right away. That's what I'm looking for. Okay, what do we do on line 6? Line 6 decrements the value of x. X goes from 6 to 5. And then where do we go?
2.
We go back to the beginning of the loop, which is on line 2. So once again, I'm looking for this transition because I want to make sure that everybody understands at the end of a loop, we have to go back to the beginning. That's the whole idea of a loop, is to go back to the beginning. Are there any questions at this point about what I'm looking for or the trace itself? Okay, so at this point, you might think, well, that's going to be very boring. We'll just have to do this like 5 more times, then we get out of the loop. Well, the next iteration is not quite as boring as this one. We still have to evaluate the condition of the loop. X is greater than 1 is still true. We go to line 3 in this case. Line 3 is still asking the same question. X equals to 5 is true this time. Then where do we go?
Line 4.
Line 4. And line 4 changes the value of x to 3. So we are skipping 2 already. And then where do we go?
6.
Aha, we go to line 6. We get out of the conditional statement. There's more stuff to execute in the body of the loop. Line 6 is outside of the conditional statement. So when you're done with the conditional statement, you still have to execute line 6. So now we execute line 6. What happens to x?
2.
It goes from 3 to 2. So what I'll be looking for this time is the condition of the conditional statement being true. And we go into the conditional statement. And when we get out of the conditional statement, we have to continue with the assignment statement after the conditional statement. So those are the things that I'm looking for with these few lines. After line 6, where do we go? Well, go back to line 2. X is greater than 1 is true one last time. Then we still have to go into line 3. X equals 5 is false again.
I have a question.
Yes?
When we went to, remember, like, you go to line 6 after 4, can't you go back to line 3? Because even though it'll make it false anyway, so that means, like, it'll be, like, kind of like a...
No.
Not a good step or not?
Nope. That's not how the computer will behave.
Okay.
Remember, we are all computers in this class. So we have to understand how the computer will actually execute a program, and the computer will, after line 4, it will go to line 6, and line 6 is important because it does decrement the value of x by 1, so it goes from 3 to 2. Okay. In this case, x equals 5 is false on line 3. We skip all the way to line 6 again. It becomes 1, and then where do we go?
2.
We have to go back to line 2 first. X is greater than 1 is false, and that will get us out of the loop and get to post. So this is also one of the transitions that I would definitely be looking for, is we don't get out of the loop after line 6. We have to get back to line 2, then we get out of the loop. Any questions about this? No questions? Okay. So I'll save this file into today's folder as... Uh-oh, where did it go?
You're saved as untitled.
Did I?
Yeah.
Yeah, I would.
Untitled.
Okay. Save it again as exam 1 Q1 A. There we go. All right. Let's take a look at the second version of this exam, of this question. I don't think you guys will be interested in looking through all of these variations because they're so similar. I don't think it's going to be very interesting to look at all of those. Is that close enough to the one before?
Yeah.
Close enough? How about this one?
Yep.
Yeah? You can see that the numbers have changed. Sometimes I use decrement and sometimes I use increment. But in the end, I think the number of iterations are exactly the same. And the logic that it has to exercise are also exactly the same. So I think we can move on to the next question. Okay? Now, if you have a particular version of this question that you think is significantly different from what we have talked about, do let me know, and I can go over that particular variation as well. I just want to move on when there's no need to. Okay, here comes question number 2, which is probably one of the most important or most nasty questions of the entire exam. All right, so here is the code. Let's see. That's better. That's all I need to expose. Okay, so this is the first variation. The first variation like this, there are different variations, but they all exercise about the same thing. After the exam, someone, not with this one, when we get to that one, I'll explain that. Okay, so first of all, we have to reverse and go backwards. So let's see, what we can do with that. All right, so this is, I'm going to save the file to its own file first. And this is going to be exam1q2a.txt. All right. What we know at this point is this. Post 29 is this, and line 29 looks like that. The question is, what can I say about pre-29? We keep everything except for x. Okay, very good. And remember, in your test, you don't have to explain all of this stuff here. I just need to know what pre-26 is, and then you have to go forward to prove that your pre-26 is correct. All right. Now that we know what is pre-29, we also know what is post-28, because post-28 is the same as pre-29, because lines 28 and 29 are sequential. Okay. We know that the post condition of line 28 is this. What do we know before that? Forget about all the rules that we use in this class. If I tell you that after I add y to z, z becomes what? 9, and y has a value of 4. Can you tell me something about y and z before line 28? Yes. What can you tell me? Z is 5, and y is 4, because I haven't got a chance to change y yet. So are there any questions about pre-28 being z equals 5 and y equals 4? Any questions? Okay. So that means post-27 is the same thing, because those two lines are sequential. Okay, because lines 27 and 28 are sequential. Okay. Now that we know after line 27, y gets a value of 4, can we say something about y before line 27? Or can we say something about x before line 27? Okay, that's right. Okay, so pre-27 is that we don't know anything about y anymore. I can still say something about z. Z equals 5 is still there. I cannot say anything about y because we just overwrote the value of y. But can we say something about x? 2. X equals 2. Okay. Now we can get back one more step. Post-26 is the same as pre-27 because those lines are sequential. Can we say something about pre-26 in this case? We know that after line 26, x gets a value of 2, and line 26 is incrementing the value of x by 2. So what is the value of x before that? 0. X has to be 0. So z equals 5 and x equals 0. Oops. Is the precondition of the whole thing. We cannot say anything about y because, if you say something about y, that's probably okay. Well, it's not okay, but I won't, take all the points off because whatever you say about y and in pre-26, is not relevant. It will still go through the code, and by the time you get to here, y will still end up with some other value. So I cannot count that as wrong, but yet at the same time it's not always true. But this is always true. If I tell you that after line 29, this condition is true, I can always go back to line 26 and this condition has to be true too. But if I say something about y, such as y equals 25, sometimes it may be true, but other times that may not be true. This, the highlighted portion in the editor, has to be true. Are there any questions so far? Yep, go ahead. No, go. Yep.
Statement 6, z equals 5. How did you get that again?
Z equals 5?
Yes.
It comes from this line here. Because after line 28, we know that z becomes 9.
Yes.
At that point, y had a value of 4.
Got it.
So that's how we can reverse that. Yep, go ahead.
So on the actual test, do you have to show that entire right?
In the actual test, you don't have to write this portion.
Okay, as long as you just have.
You have to start with this portion here, but when you start with that portion, it has to naturally get to the post condition that we arrive at.
Okay.
Yep, but you don't have to explain how you got the initial condition.
Okay.
Yep. Yep.
Can we leave z equals 9 minus y?
Say again?
Can we leave it z equals 9 minus y
Z equals 9 minus y
as the precondition?
as a precondition? Unfortunately, you cannot because y got changed right in the middle. So you cannot get past that point. In other words, you cannot infer the value of y past line 27 when you go backwards. And as a result, z equals 9 minus y does not work anymore because you have just lost track of the value of y. So I will still give you some partial credit because you were able to reverse it, but you did not stop, when you have to stop because there's no way to know the value of y once you get past line 27. And that's why grading this question is going to be difficult because I have to give you guys partial credit, but it's hard to have a partial credit scheme unless I know all 20 gazillions ways to get it wrong, but partially wrong. I personally prefer all or none grading, but I don't think you guys would like that. So you have to go for a more fair way of grading it. Okay, so now that we know the precondition is like that, how do we know that this is actually right? We have to go forward again. Now going forward is a whole lot easier, right? Going forward means you can apply all the rules. So once you know the rules, you know how to do it. All right, so let's apply the rules to line 26. What do we have to say on line 26? On line 26, what is the first thing we have to know?
Right-hand side.
Okay, the right-hand side
Refer to left.
refers to the left-hand side. The right-hand side is x plus 2. The left-hand side is just x. So the right-hand side does refer to the left-hand side. Is it reversible? The right-hand side is reversible because if f of x is x plus 2, what is the inverse of that? X minus 2. Okay. So once we know all this stuff here, we know that we have to use the substitution rule. And to use the substitution rule, if you remember from your homework assignment, is a 3-line deal, right? The first line is just saying how the pre and post conditions relate to each other. 326, we replace the variable that we are changing with the inverse function applied to that same variable. The second line expands, these things. Pre-26 is this here, so we copy that to here. Obviously, you could not copy and paste. Okay. And then the next line is just applying the substitution. So it becomes z equals 5 and x minus 2 equals 0. And if I want to keep everything just like, there's no need to simplify. If you want to simplify, that's good. If you can say x equals 2 if you want to, but leaving it like this, it's fine. There's no problem like this. Do we have any questions about post 26? Okay. Then you can say pre 27 equals post 26 because the lines are sequential. Okay. What about line 27? How do we know which rule to apply? Which question do we ask? Does the right-hand side refer to the left-hand side? Okay, so that's the first question to ask. And the answer is, okay, on line 27, the right-hand side does not refer to the left-hand side. Then we know right away which rule to apply. Which rule do we apply here? Okay, use the forget rule. When we use the forget rule, the post condition relates to the precondition using a forget operation. What are we forgetting? What components are we forgetting? Components that contain y. Okay. And what else do we know after this? Y equals x plus x. Okay. X plus x. Okay. Yep.
So you always, okay, now I just actually learned how that works. So you always use the left variable, like, you know, whatever the left variable is on the left side.
The left-hand side only has one single variable.
That's
so
what you want to forget, right? If it's not.
You are forgetting components that mention that.
Okay, so like if it was x plus y, that means like the left-hand side, x plus y is to y, that means you would forget y, right?
If x gets x plus y, then it's actually reversible. Then you cannot use the forget rule.
Oh, well, it's like I'm just, that's fine.
Well, we have another chance, you know, down here to forget something, so we'll wait for that chance. Okay. So now you have to substitute and put in the actual pre-27. Pre-27 is the same as post-26, which is this portion here. And y still equals x plus x. Is the forget operation meaningful? Are we actually going to forget anything? In other words, there's no mentioning of y here, so there's nothing to forget. But we still have to tag on y, you know, is x plus x at this point. Okay. You can leave it like this, or if you go one step further, it makes a difference at the end. But I'm not, you know, counting on anyone in this class to make that one extra step. The one extra step is to resolve the value of y the best you can. Because right now we mentioned that y equals x plus x. We also say that x minus 2 is 0. So exactly. Now it makes a difference. So we'll take a look at, you know, what difference does it make. Now this step again is not required. So if you don't perform this step, you know, it is okay. I'm not going to take any points off. But I do want to show you what happens when you apply, you know, these rules, or when you know, infer the values of something as much as you can, as opposed to leaving it the way, you know, like this one here. Okay, it does make a difference later on.
Why don't we simplify x too?
Oh yeah, we can simplify x too, but the effect is not as dramatic as this one. I mean, let's go ahead and simplify that. X equals 2, like that. Okay, so let me make sure that this is, we know that this part is optional. If you do it, it's really good. If you don't do it, I won't take any points out. Okay, now that we have post 27, we have pre 28. Pre 28 equals post 27 because the lines are sequential. Okay, and once again, which question do we ask first? Okay, on line 28, the right-hand side refers to the left-hand side. Is that right? The right-hand side is z plus y. The left-hand side is z all by itself. Does z plus y refer to z?
Yes.
Yeah, it does. Okay. The next question is it reversible?
Yes.
Okay. F of z is z plus y. F prime of z, the inverse function, is z minus y. Whatever y is, y can be 0, y can be 1, can be 2, can be 20, It doesn't matter, because whatever you add to z, you can always undo it by subtracting the same amount. Okay, so we have to use the substitution rule. So when we apply the substitution rule, the post condition of line 28 is based on the precondition of line 28. We have to perform the substitution operation. In this case, what are we looking for?
Z.
The variable on the left-hand side, which is z, and we are replacing that with
Z minus 1.
the inverse function applied to z. So we have to copy and paste this portion here. And this is where it gets a little bit kind of difficult, because I have to give you both versions. Z, and then this is z minus y. So I'll do the first option first, and then we'll do the second option. When we actually apply the substitution, this gets changed. So I'll just go ahead and copy and paste it first, and then we'll change z to z minus y. Is that okay so far? And this is the answer that I'm looking for. All I'm looking for is just a mechanical application of the substitution rule. Okay, you have to know what you're substituting it with, and what is the result. Okay, if you do the further part, it's even better, but this is what I'm looking for. This is the minimum that I'm looking for. Now, let's take a look at the optional part. The optional part is to use this as a precondition instead of the other one that we were using. So let's use the optional post 27 and then see what happens. The other portion is still the same. Z minus y is still the same. So we change z minus y to be 5. Is there a way for me to push this even further? Can I resolve the actual value of z?
Z equals yes.
Z equals 9, right? Because we know that y equals 4. So this becomes z minus 4 equals 5. And then we add 4 to both sides. We have z equals 9. So you can see that one version seems to give you a better result than the other version. Now, most of you would probably be able to see this and say, well, we can still infer all of that stuff, right? You can still infer all of that, because this will tell us x equals 2. That's good. Well, once we know x equals 2, this will tell us y equals 4. Once we know y equals 4, this will tell us that z equals 9. So it appears that both versions will give us the same result, the exact same result. Except the last line is going to change that. Okay? The last line will make a big difference depending on whether you perform the extra steps in post 27, because if you do all the extra steps in post 27, we're only going to lose x. On the other hand, if you did not do the extra steps, we lose a lot more than just x. Let's go ahead and take a look. So now we are moving on to the last line, which is a very simple line. The last line is 29. What do we say on line 29? The right-hand side does not refer to the left-hand side. Okay? So which rule do we use in this case? Use the forget rule. Okay? Let's go ahead and apply the forget rule. It seems very easy, but it makes a huge difference in this case. So we say post 29 is forget pre 29. And what are we forgetting? Components containing x. Okay. And what else can we say after line 29? X equals 2. Very good. So now we find out what is pre 29. And pre 29, oh, I forgot one thing here. Pre 29 is post 28 because those lines are sequential. Okay. So now let's take the first one first. Okay, let's take this one here, which has no algebra applied to it. So we look at this mess here and say, we'll forget everything that mentions x. And we'll also now that we now know that x equals 2. And let me make this a little bit wider. Are we going to lose anything? We're going to lose something here. In fact, we'll lose 2 items. We'll lose this one because it mentions x. We'll lose this one too because it also mentions x. Right? So what do we have left? We only have this part left. But we still know that x equals 2 after this. Is that okay? If you do it like this and arrive to this conclusion, even though it is not the same as the post 29 that was given in the question, I'll still give you full credit. Okay? If someone somehow tried to, wiggle in something to make it look like the final result, that person will actually get points deducted. Because I want to see if you guys can identify which rules to apply and how to apply the rules. Okay? As long as you do everything fair and square, even if the result does not seem to be the same, it's okay. Now let's take a look at the optional part. The optional part depends on this one as our pre-29. Okay? So pre-29 now knows everything, every variable. We know the exact value of every variable. But we still have to forget something because we still have to forget everything that we know about x. And after this, we say x equals 2. Okay? Of these 3 conditions, only one mentions x. So we have to lose that one. So the result is z equals 9 and y equals 4. And we still have to append x equals 2 at the very end because that's the effect of the assignment statement. So it is just coincidental in this case that what we are losing is the same thing that we are gaining. But that's not always guaranteed. All I have to do is to change this assignment statement to x gets 3, and then change post 29 to x equals 3. Then they are not exactly the same anymore. But you can see the effect of the optional step. Does everybody see what that one extra step can gain? Okay, let's take a look at what the extra step is. The extra step is this part here. All that I did was to say, well, since we know what x is, we know what y is exactly too. So from here to here, from this step, y equals x plus x, to this step here, y equals 4, we have done one thing that is very important. We have just isolated y from changes to x. We can make changes to x after this all we want, but it doesn't change what we know about y anymore. Is that making any sense? Okay. But I'm not counting on this step here. As I said, this step is optional. If you stop right here, that is perfectly correct already. Are there any questions about this? Yep.
So how would a computer see this?
How would a computer see this?
As option, or
the computer will actually carry on this because the computer actually resolves the values of every single variable all the time. So when you trace it, it will always know the exact value of each variable on each line.
okay.
So that's why the computer will go. The computer doesn't really solve the equation. It's just that when it executes, it always gets a definite specific value in each variable.
Okay.
Yep.
Can I ask if line 27 was x, or x plus x gets stored into x?
Sure. Okay, that's an alternative, right? A very alternative question. So let me save this one first, and then we'll look at the alternatives. Because this one does have 5 alternatives, just like the other ones. And the alternatives may look different, or different enough in this case, to warrant a separate look. So let's take a look at those. You mean this one?
Yeah. Would you just combine the 2 x's, make it 2x?
Correct. Yep. So with this one, okay, I think it has enough similarity to the other one. So we can just look at line 26 in this case, because line 26 is the only line that is significantly different from the other. So the question is line 26 reversible? Is there an inverse function for it?
Yes.
No.
Why not?
Because you cannot reverse with x. Because if 2 plus 2 equals 4, then 4 minus 4 is 0.
What is the other way to say x plus x?
1/2 x.
2 times x.
2 times x. And is 2 times x reversible? X minus x is not reversible because it is always 0. But x plus x is not. So it is reversible. When I wrote the test, I did not actually consider this one any harder than the other one because, you know,
Much harder than
well, maybe to some people. I mean, you know, to some people, just flipping the sign makes it difficult. So I cannot, you know, anticipate, you know, how. Okay. Any other questions? No. Does anyone want to look at the other variations? Let's just take a quick look, because I cannot remember all the variations either.
Oh, there you go.
So this is another variation. You know, we have, this is reversible. The second line is reversible as well. The third line is not reversible. And the last line obviously is not reversible. So if you look at the number of derivations using substitution and the forget rule, I think they're all the same. And then this is variation D. Do you know how much time it takes for me to come up with all the variations? I actually kind of enjoy that. I don't enjoy the grading part of it. This is another variation, you know, same thing. We have a line 26 is reversible, line 27 is not reversible, line 28 is reversible, and line 29 is also reversible in this case. So they are slightly different, you know, there's you know, certain variations to it. And this is the last one. This is the last variation. Line 26 is reversible, line 27 is reversible. In this case, every single line is reversible. Okay. Are there any questions? No questions? I forgot to comment on one thing. Let's take a look at the title page, or the first page of the thing. Someone is going to, you know, not be happy about this. Look at the instruction here. What does that mean? Last name first. The majority of the class did that. A few people did not. So what should I do about what should I do about the few people who did not? Well, I'm thinking, you know, since, you know, we are running, you know, this as an algorithm like in a computer. So if someone gives me the first name as the last name, I will not be able to find the entry on the roster. So, you know, the score, there's no way for me to enter that score into the grade sheet at all. So I think that's, you know, what I should do, you know, if I were a computer following the algorithm.
Retest.
Hmm?
You need an error checking routine.
Error checking routine, but that's not my error. It's not my error. Or I'll just wait for a student with that last name to enroll in the class. To get that credit. Okay, so I can see some people's filing, you know, name change forms now. I would like to change my last name to my first name and my first name to my last name, just so that I can get a credit. Okay, this is the third question. The third question looks like this. It's also a trace. You know, I think this one is not really that hard. So I'll go through one, and then, you know, the next one. The variations are different. Sometimes I go for the if, the then portion. Sometimes I go for the else portion. And, you know, the loops, you know, also get flipped. You know, sometimes the while loop is up here, the repeat loop is down there. The direction may get changed and stuff like that. But they are all basically the same. So let's go through this once. I don't think this will take much time though. All right. We have line number, and how many variables do we have?
3.
We got three variables.
No
Yeah.
comments?
Hmm? We got x, y, and k.
Comment first.
Any comments?
We need comments too. Yep. Okay, fine. Comments, line number, x, y, k. K really doesn't change, so it's pretty much constant the whole time. And then we'll shrink these two, shrink this one, and get started. The precondition is given to you. I wrote down line 1, so I have to write down on the whiteboard, it's actually the precondition. So let's go through this one. It's 1 to 125. So 2, 125. Okay, so getting back to the algorithm itself. All right, so now we start with the actual line 1, and we evaluate the condition. X is less than y is true. Then where do we go?
3.
We go to line 3 in this case. Yep,
If line 1 was false, you would skip to line 6, right?
correct. Yep.
Back on the sorry, you have the list already set up.
Mm-hmm.
They said line 1 is x equals 2, y equals 100, k equals 25.
Yeah.
Instead of pre.
Correct. Well, that's why people in the class actually get the benefit that I fixed it on the whiteboard. If you're taking it outside of the classroom, did you comment on it? Did you write down the condition right here?
Yeah.
Don't remember.
Okay. If you give me the condition, it will still be correct, because in this case, what this line is saying is, on line 1, we know that x equals 2, y equals 100, and k equals 25. So you can still start with this and just give me the condition of the conditional statement on that line. So that will still be okay. Okay? Because this is a shorthand. Remember, when we don't write down something in a cell, it's a shorthand to mean that it has the same value as the previous cell. So it will still be okay as long as you write down the condition or the result of the condition. Okay. So let's go back and trace the code. All right. We are on line 3 in this case. X gets x plus k. So what does x become? 27. Then we go to line 4. Line 4 has to evaluate the exit condition in this case. X is greater than or equal to y is false. Then we have to go back to line 3. I'll be looking for this transition so that someone can show me that when the condition is true, we go to the then portion. I'll be looking for this transition here, and also the evaluation of this condition, and also from line 4 back to line 3, because that's the whole idea of a loop. On line 3, we are adding 25 again to 27 to x, so now it becomes what, 52? And then we go back to line 4 again. So this one does involve a little bit of chore because it has to go through this a few times. Then we go back to line 3 again. It becomes 77. And then we go back to line 4. X is greater than or equal to y is still false. And then we go back to line 3, and this time it becomes 102. We still have to go to what? Line 4. We cannot get out yet. Okay, we have to go to line 4, and then we have to indicate the exit condition is now true. And then what happens?
Post.
And then we go to post right away. So I'll be looking for these important transitions. Are there any questions about this trace?
So you don't go back to line 1.
We don't go back
You
to...
don't go back to line 1, and if you
No.
because that would make it false, and then you would go to well. No.
If we go back to line 1, that turns it into a loop. And this is not a loop, it's a one-shot. Because a conditional statement comes in from the top, it branches off one way or the other way, but it doesn't matter which way you go, because after you perform either the then portion or the else portion, you still have to merge and get out right away. You don't go back and evaluate the condition again. So if someone stays here back to line 1, that actually will get points deducted because it does not exit right away. It should exit right away. So let me save this file. And we'll name this exam1q. Is it Q3? A. Does anyone want me to go over other alternatives? Yep.
Go over the one that has like while in the second line.
Okay, you have to tell me whether this is the one that you're looking at. Because I don't remember which variation is which one.
That's one.
Is that the one?
Yeah.
That's not the one I want.
It'll end up in the wild loop.
Okay, well, I'll just kind of go through this one and try to explain it verbally. If you guys are not happy with the verbal explanation, then we'll trace it. Okay. But to get to this one, we actually have to look at the variables as well. So I have to expose a little bit more. Okay, get rid of this part here. Okay, this is the initial condition. X equals 20, y equals 1, and k equals 5. So initially, is x less than y? Is that condition true or false?
False.
It's false to begin with, so we'll go to line 6. Line 6 says as long as x is greater than or equal to y, we want to subtract x. We want to subtract k from x. Okay? So then the next line, is x greater than or equal to y to begin with? Is greater than or equal to. So we have to go in, it will decrement x to 15, then it will go back, the condition is still true, it will decrement it to 10, it will go back, the condition is still true, 15, 10, and then 5. 5 is still greater than or equal to 1, it will go back, and the last time is it will decrement from 5 down to 0. At that point, 0 is greater than or equal to 1 is false. Then we go from line 6 to post in that case. Okay? Is that okay, or do you guys still want me to actually write it down and trace it? That's okay? All right. Let's look at another variation. Okay, how about this variation? Do you guys want me to go through this one?
Yes.
Okay, let's go through this one. Okay, so we have comments, my number, x, y, k. And k is 5, y is 1, and x is 20 to begin with. All right, this is our precondition. Sorry?
Do you mind if I go?
No, that's fine. All right, so the comments is x is less than y is what, initially? Is x less than y?
False.
It's false. Okay. So if that is false, we have to go to the else part. And what do you think the else part do?
7.
Okay. The else part will go to line 7. Line 7 will do what? It will decrement x. It will decrement 5 from 20, so it becomes 15. And then what do? We go to line 8. Line 8 has to evaluate until x is less than y. X is less than y is
False.
false. And then what do? We have to go back to line 7. This time it becomes 10. Then we go to line 8 again. X is less than y is
False.
false. We go back to line 7, goes down to 5. Then we go to line 8, it's still false. We go back to line 7 again. 5 decrements all the way down to 0 in this case. We go to line 8, and it is now true. And then we go to post. Because we still have to get out of the loop, but getting out of the loop has to be the result of evaluating the condition of the loop. Is that okay? For this one? All right. So let me save this one too. I'm going to save every single version that I work on. This is Oh, which variation is that? Exam 1, Q3, I think it's C or D. C? It doesn't matter. I think it's C. Yep. Does anyone want to go through D and E? Yep. Okay. So let's take a look at D. Yeah, let me close these first, otherwise there will be too many of these up. Don't you think grading these will be fun?
You haven't graded it yet?
Not completely. Remember, I have to figure out, how it can go wrong to give you guys partial credit. I have done this before, not with a class like this big, with a class of 20 or so. I would come up with a partial credit scheme, and as I go grading, I go like, oh, this person is wrong, but it's not completely wrong, it's partially correct, but it's not one of the things that I have already planned for. So I have to make, another rule for that. And because of that, I will say, okay, but the partial credit that I have assigned to all the other things does not seem right anymore. I have to readjust and then start grading from the beginning again. So it's helpful to see the answers of everybody first before I even come up with a grading scheme. Okay, so is that the one that you have? Okay. So in this case, if x is in fact less than y, which is the case here, we'll go to line 2. Line 2 is true to begin with. We'll add 12 to x. So x goes from 5 to 17. We go back to line 2. 17 is less than 50 is true. We go back to line 3. We add 12 to 17. That will turn it to 29. We go back to line 2. 29 is less than 50 is true. Then we go back to line 3 again. 29 plus 12 is 41. We go back to line 2. 41 is less than 50 is true. We go to line 3. 41 plus 12 is 53. Then we go back to line 2. 53 is less than 50 is false. Then we go to post. Okay. Any other questions about this one? Do you guys want to go to variation E? No? You have enough already? Okay, this is the last question. Last question is question number 4. And this is one of the fun questions. It has to do with dead branches. You have to identify the dead branches in the code. Okay. So let's make this a little bit taller. All right. And we'll zoom it like this. Okay, we'll pan it so that we can see the whole thing. Okay, so you have to give me concrete values, which means specific values for x and y, so that z equals 0 at the end of this code, z equals 1 at the end of this code, and so on. So this is variation A. Can someone give me some specific values so that z would get a value of 0 in this case?
X equals 6.
X equals 6. Y is 7. That would do the trick. Very good. The first one is always easier because you don't have anything else to consider. What about the second one, z equals 1? Now, it's a little bit tricky because you cannot use the same test case anymore.
X equals 6, y equals
Minus
5.
200.
Yeah.
Right? Because all you have to do to get z to become 1 is x has to be greater than 5, but you have to make sure y is no longer greater than x. In other words, another really easy case that will work in this case is x equals 6 and y equals 6. That will work too. Because when x and y are exactly the same, then y is not greater than x, so we won't go to line 2 to give z a value of 0. Is that okay? All right, what about line 6?
6. X is 3, y 6.
Exactly, because you have to make sure x is not greater than 5, but then you have to make sure that y is greater than x. So having x have a value of 3 and y having a value of 4 would work too. Okay. What about line 8?
Not possible.
Line 8 is not possible. Why is it not possible?
It's already already covered.
Exactly. All of those cases have been covered already. So there's no way for line 8 to happen, and then you have to indicate that. So the question says, if a case is impossible, state that it is impossible, and briefly explain why. You can just explain, all of those conditions have been covered. Okay, so there's no way for us to fall to line 8. What about line 9? Is it possible for z to get a value of 4? Yeah, it is.
Yeah.
And what would that be?
X is 5, Y is 2.
Yep. It doesn't matter what. Y still has to be less than or equal to x. Otherwise, this case would cover that. But you just have to make sure that x is greater than 4, but not greater than 5. How do you make x greater than 4 but not greater than 5?
5.
5, exactly. So when x equals 5, then, and you have to make sure that y is also less than or equal to x. So that means, when x is 5 and y is 5, then z will get a value of 4. Is that making sense? What about line 12? Can we ever get to line 12?
Yeah.
How do we get to line 12? Give me one specific example.
X is less than 4.
Yep, that will do it. You just have to make sure that this condition is false, this condition is false, and this condition is also false. And there are plenty of cases where you can find that. Any questions about this? Do you guys want me to go over the other variations? They're similar enough. I mean, they're all about the same. Okay. Are you guys feeling a little depressed?
Yes.
Well, good thing is it's only 20% of your final grade. Yes?
How does this test compare to textbook?
In terms of difficulty, I really, that kind of question, I cannot answer. Not because I'm not honest, but because my opinion, seems to be different from what other people think. I would say, from my perspective, it will be dialed to about the same difficulty level. But there won't be any pre and post conditions in the next test. So it'll all be tracing. Okay? Is that better or worse?
Better.
We're not done yet. We still have 10 more minutes to go. Okay. You can stretch if you want to. I mean, I know you guys are, have been tense, sitting here, just go like that. Okay. Sorry?
Roll.
Take roll. Ah, very good. I almost forgot. Okay, so exam 1 is 20% of your final grade. Okay, let's say someone is unfortunate and got a flat 0 for exam 1. Okay? Okay, 0% for exam 1. So that's a confirmed 20% loss from the final grade, right? So that person can still have up to 80%, to be determined. Okay, we have some homework, done, and then we have some other homework. I'm assuming most people will get the homework done, and get most of the credit out of the homework assignments. So with 80% still available, what is the highest possible grade for this person who got a flat 0 in exam 1? That'll be a B, okay? This is a quick quiz from the syllabus. What is the lowest percentage to get a B? Come on, you guys know that.
76 or something.
62.5% is the low. Is it 62.5 or 67? 62.5%. Yep. It is 5/8. Okay. So even if someone get a flat 0 in exam 2, that person still has quite a little bit of leeway in terms of getting a B. You guys see what is happening here? Okay. So what if someone gets a 0 in the first and the second exam? That person will now have, that person has just lost 40% confirmed with the exams. So that person only has 60% left to be determined. So that will be the final exam and the homework assignment. What would be the highest grade that this person can get? It will be a C, but 60% is pretty much the high ceiling, the ceiling of a C. So this person has another 25%-ish to play with before dropping down to a D. So that means there's a lot of leeway in this class. Yep.
I don't see the leeway because if you got the first and second midterm tests wrong, what's the chance that you're gonna get the final correct?
People can pray.
Or study.
Miracles happen. I mean, I believe in disasters just as much as I believe in miracles. So there's someone who gets 100% here and 100% here can still end up with a 0 in the final exam. Okay?
By not coming.
Huh?
By not making it to class.
May not make it to class, but being sick is one of the excusable things, so that's okay. Okay, so I'm hoping that most of you will not be too depressed, because of the first exam, but it does, give you an idea of the difficulty level or what I will be testing you guys on. Because I'm not testing you guys on memorization. There's no memorization questions. It's open book, open notes. Okay, it's all about, can you apply what you have learned in the class? That's the key. We still have 9 minutes to go, so, we'll continue the lecture a little bit here. Watch a video. Let me see if I can install Scratch. Okay, I think that would be a good distraction for you guys, just to get your minds off, the exam. The session after the exam, when we talk about the correct answers, is what I usually call the salt rubbing session. You get a wound, you get a road rash like this, and then you get some rock salt and go like that. It's gonna hurt, but guess what? It will also stop further infection. So it's actually a good thing. It's painful, but it's good. You can try alcohol too.
Because if you rub,
That's gonna stink. Oh, try new skin. Does anyone know what is new skin? Yeah, it's kind of like a nail polish thing. Yeah, and so you can basically just use it to cover up your wound, except it stings. It stings much more than alcohol. All right, so let's go ahead and look at Scratch. Okay, some of you have played with Scratch already because you have taken the class from me in cisp300. This is Scratch.
sushi shop.
Oh, they have lots of fun stuff. This is kind of like YouTube, except for programs. Okay, so these people have all written programs in Scratch. It's a programming environment, and it's multimedia, and it's fun. You can write your own game. You don't have to learn any syntax either. Okay, so let's still go ahead and see if I can download and install it. In the past, it would not let me do that. Oh, skip. Okay, so we have Ubuntu here. So let me click on this. It's not exactly Ubuntu, but it's close enough. Do you want to keep? Yes. It's really quite fun. If you guys want to learn how to use Scratch, I'm not going to cover that in this class because that's not what this class is about. But if you want to learn how to use Scratch, you can just go to YouTube and just type in Scratch programming or Scratch tutorial. There are tons of tutorials done already on this very topic. For people who are more hands-on, this is actually a very good program to try out. Because otherwise this class is kind of dry and theoretical, but this will change your perspective. So we'll go ahead and install that package, Scratch. Oh, okay, fine. I have to become this super user. Superman. In the past, it has a dependency problem, so I had to do some surgical things to it for it to install. But this is a newer distribution of my live distribution, so maybe it will just do it. It's still alive. The flash reader is still ticking, so I know it's still alive. Okay, it's still complaining. I cannot get it installed. Okay, fine. Let's watch YouTube then. Even better, it's getting better and better. So we'll go for Scratch programming. Scratch lesson 1 of 10.
Welcome to the first lesson of Scratch. In lesson 1, we're going to create our very first sprite. Let's start. Delete start. Delete this existing sprite. Click here to bring up the paint editor. And to create, click the circle tools. Make sure it's hollow. Click hollow. Create a circle for face. Another circle for eyes. And a flatter circle for ears. Okay. For eyes, we want to also add the pupil. Then, copy the eyes using stamp tool. Select where you want to copy, and then put down the copy. Go do the same for the ear. Click the stamp tool, select the ear, put it side by side, and then for ear, I want to trim it. Trim the ear. Okay, and then fill the face and the eyes with color.
This is not a programming part.
And then you pick your color.
Let's skip.
For eyes, white.
I know it's entertaining, but you know. Come on. You can see that the music has changed a little bit, quite a bit. It has no logic. Okay, skip. So the music has changed again. Okay, this is the actual cool part. This is the programming part. Did you guys see what just happened?
Yeah.
To build a program, you have all these basic blocks already. You just drag and drop the blocks into this portion here, and that's how you write a program. Okay, and that's how you write an expression too. If you want to say, y gets updated by y plus x. You don't just say x equals or x left arrow y plus x. You have to drag these blocks. There's one block for adding, one block for assignment, one block for conditional statements, one block for pre-checking loops, and so on and so forth. So editing and making your program is just building these things. You're just pulling the blocks in. Now, it covers everything that we talked about in this class, all the conditional statements, the loops, and whatnot, up to this point. It does not have subroutines, and that's the only reason why I don't use this, because it does not cover the topics of subroutines, okay? But it's really fun, okay, because, if you look at all these different blocks, the purple ones are sound, the green one is pen, and then you can also control the motion of these sprites, okay? So you can make your own game. You can make your own game, you can make your sprite go in different directions, and you can detect when the sprite collides with another sprite. And then you can do something when they collide. You can make an explosion, okay? You'll keep track of the score, and so on and so forth. So I would suggest, if you guys want to get some hands-on experience with programming, with actually using the conditional statements, the assignment statements, the loops, and so on, I would advise you to go to Scratch scratch.mit.edu, and just play with that. It's Java based, so you should be able to get it installed in most systems. Okay. Any questions? Next time I'll bring my own Scratch program to the class. I will write the Hangman program, and you will see Hangman is not really that simple to write. All right, I'll see you guys on Thursday.